Okay, I'm going to finish up that portion of the video that I was unable to do yesterday. Or not unable, but the video was getting a little bit long, and I was honestly a little bit late to something, so had to cut it real quickly. Want to finish this one off. So, this is the end of the second part of our review, and just have a handful of questions to go through here. So, first of all, let's look at this one. Researchers conducted a study about the effects of reading to children. They measured the number of words that two groups of 5-year-olds knew. The data are summarized in these density curves. So if you compare these two, I want you to notice a couple things about it. On group one, obviously it goes a little bit higher, gets a little closer to 0.15, where group two doesn't. It just barely kind of covers the 0.10. But um, group one is the data is a little tighter, like it's a little closer together, steeper, I guess you could call the curve. Where in group two, it's a little wider. And if you notice, the x and the y axes are the same. So we can really compare the way these two look because they're looking at the same x and y axis. So here's the question: determine whether each statistic was greater for group one, greater for group two, or equal for both groups. So what is it we're looking at? What's the statistic? Mean and standard deviation. So first of all, let's just talk about mean. Mean means average. Your average is higher. So I'm going to look at these two graphs and I'm going to look at which one goes higher. That's going to give me the higher mean. Well, we already talked about this. It's definitely going to be group one. Group one is going to have a higher mean. Now, there's no way we could calculate what that is. If you wanted to, I guess you could say it's like 0.145. You can't really tell. It doesn't matter. You just know that the mean is greater for group one. Now, the next one is standard deviation. Now, to understand standard deviation, we talked about the spread of your data. Like if your data is more spread out, the standard deviation will be greater. It'll be a bigger number. So if you look at group two, it's more spread out because this one's steeper, this one's more spread out. This standard deviation will be greater. It'll be a bigger number, and that's what gives it more of that width. So for this problem, the mean is greater for group one, and the standard deviation is greater for group two. All right, let's move along. This is number 52. It says a factory packages bags of flour. The weights of the bags are normally distributed with a mean weight of 5 pounds and a standard deviation of 0.08. Now, don't forget that normal distribution is on your reference sheet. Now, let's see what this question says. Quality testers find a bag of flour that weighs 4.95 pounds. What is the Z score of this bag's weight? Okay, so look, Z scores also you can find, can't write. You can also find Z score on your formula sheet. In fact, I'm looking right at it right now, and it says Z score, colon, Z equals. So Z equals X minus mean divided by the standard deviation. And it's literally all typed out like that. Of course, it says standard deviation. So all I got to do is just take all these values. So to find the Z score, I should have all three of these things. I should have X. Well, what is X? That's this particular bag of flours, 4.95. I should have the mean. Well, earlier up here, it told me that my mean weight was 5 divided by, and I should know my standard deviation, and they told me that too, 0.08. So real simple question. All I'm going to do is go alpha y equals, number 1. I'm going to do 4.95 minus 5 on top and divide that 0.08. Whoops. 0.08 on the bottom. Push enter, and that's negative 0.625A. Pretty simple, wouldn't you think? All right, let's keep on cruising along here. Number 53. Jessica wants to estimate the average age of students at her college. She sends a letter to all the students at her college describing her research and includes an anonymous survey asking for their age. Which statement best evaluates the data Jessica will collect from her survey? So A, Jessica's data will likely be unbiased because she sent the survey to all students at her college. Okay, now again, we're talking about collection. So will it be unbiased because she sent it to everybody? It's not about sending it to everybody. It's about what you get back. So I don't really like that one. Let's see what B says. Jessica's data will likely be unbiased because she made the survey anonymous. Again, all we're talking about is age of students. So it being anonymous probably wouldn't affect someone responding, uh, because they're afraid you might figure out who they are. I mean, that's the whole idea of anonymous. I'd do an anonymous survey if I wanted to hear what people thought about something that I might get offended about, but I want to know. That would be a reason for anonymous. That's not it. C, Jessica's data will likely be biased because she told the students that she was studying what she was studying. Again, I don't know if I even see what she was studying. She just wanted to know the age of their. That's the dumbest one in my opinion of all of them. D, Jessica's data will likely be biased because not everyone will respond to the survey. Now, to me, D makes the most sense, and here's why. When it comes to bias versus unbiased, there are certain things that will cause something to be biased. Self-selected surveys are that. You see, when I have the opportunity to choose whether or not I respond to something, you're likely only going to get certain people who respond. So you're going to get, if you're giving them an option to send it back to you, you're probably not going to get great data because you're not going to get uh, even close probably to 100% participation. In fact, I would think about this myself if I was at a college and I got something like this, I just would throw it away or I'd delete the email. So again, that's why it would be biased because not everyone will respond because it's self-selected. You have to choose to do it, and they're going to choose probably not to. I thought this one was pretty hard, number 54. You have to kind of understand the difference between a statistic and a parameter. A statistic is that you're only able to get a certain sample, but a parameter means you're able to reach the entire audience. So, on the first one, in a randomly selected group of first grade students, the average height was 45 inches. See, to me, because they tell me it's a randomly selected group of first grade students, that makes it a statistic because you're not getting the average height of every first grade student. You're just randomly selecting a group of them. So I don't think that's it. That's a statistic for sure because it's a sample. The next one, the median age of teachers at a school is 39 years. Now, to me, if we're talking about this school and the average age, well, not average, but the median, the middle age, then you're going to get every age of that teacher, of the teachers at that school. You're getting the whole group. So this one's more of a parameter because you're able to reach your entire population here. Okay. Let's look at the last one. In a phone survey, 89% of people who responded said they have internet access at home. Again, you can tell this is a sample. It's not a full group. It has to be a statistic, not a parameter. Remember, statistic reaches a sample, parameter reaches an entire population. That's the thing that you have to be able to answer when you see this, okay? 55. A company assigns each employee a random 6-letter code using letters E, F, G, and H. Which number is closest to the probability that an employee's code will not contain the letter G? So I thought this one was pretty challenging. And here's why. You got 6 letters, right? And it could be any of these 4. So technically, according to what this says, I would have the ability to get 4 different possibilities for all 6 of these digits, right? That would be the total possibilities. Remember, total possibilities is on the bottom of any of our probability fractions. So since I could get a 6-letter code with 1, 2, 3, 4 different letters, and letters can be repeated, I could have gotten 4 times 4 times 4 times 4 times 4 times 4 as my total possibilities. But this is saying which number is closest to the probability that an employee's code will not contain the letter G. So here I have all 6 of these possibilities, but none of them can be the letter G. Well, if they can't be the letter G, what are they allowed to be? E, F, or H. So that means there's 3 possibilities for every one of these values. So my probability will be 3 to the 6th over 4 to the 6th. So if I type this into my calculator, 3 to the 6th over 4 to the 6th, then I should be able to figure out which one my answer is. Remember, this left it as a fraction. You have 2 options. You can either go alpha y equals and turn that into a fraction or a decimal. You could have just typed 729 divided by 4096, and that would have given you the same value. But if you look at this, that's about 0.18. Let's go back to our page. 0.18 is A. So remember, anytime you're doing probability, you're doing number of favorable outcomes over number of total outcomes. The total outcomes on a problem like this would have been every digit could have been, every 6-letter code, every one of these letters could have been either E, F, G, or H. But specifically in this question, if you didn't want to include the letter G, the favorable outcomes would have just been E, F, and H. So only 3 possibilities. So that's how we came up with that one. It's kind of tricky, maybe, but you can handle it. Okay, a restaurant has 9 different types of fruit in the kitchen. The chef randomly chooses 3 fruits. Okay, boom, right off the bat. I hope you understand this. The chef randomly chooses 3 fruits. What's the probability the chef will randomly choose an apple, pear, and an orange? So 2 things right here. You have 9 different types. He randomly chooses 3. And it doesn't care about order. It doesn't say he randomly chooses, but you get an apple first, a pear second, and an orange third. It doesn't care about order. This is a combination problem. 9 with a combination of 3. Okay? So this is my probability. Okay? This is my total number of outcomes. This is my total number of outcomes. So this is going to be my bottom number. Now, obviously, you can see the top number. But if I go 9, and then hopefully you remember where to find this. Math, probability, number 3. Math, probability, number 3. So this is 9C3. So your bottom number is 84. So this is going to be 1 over 84. B. Okay? Next, Peter and Alex each flip a coin to see if it's fair. Peter flips the coin 10 times. Peter says the coin is not fair because 7 of the results are tails. Alex flips the coin 100 times. Alex says the coin is not fair because 52 of the results are tails. Which statement best describes Peter and Alex's conclusion? Well, think about this. They're flipping a coin. Now, from a theoretical probability, doesn't 7 seem a little high? Now, 52 out of 100, that seems almost dead on. 7 out of 10 does seem a little high, but listen, you're flipping a coin. You can't, there's not fair. It either lands on tails or it lands on heads. That's just what it's going to do. So really, that's the mindset you need to have looking at all these. So let's see what they say. A, Peter's conclusion is valid, but Alex's conclusion is not valid. So you're saying that Peter has the right to say it's not fair because 7 out of those 10 were tails? No, you're flipping a coin. B says Alex is valid, but Peter's is not valid. No, neither are valid. So both Alex and Peter's conclusions are valid? No, neither are valid. You're flipping a coin. What you get is what you get. Okay, that's the whole difference between theoretical probability and experimental probability. When you do experimental probability, you get what you get. So neither are valid. Okay, number 58. A survey was conducted. In fact, I think we had this problem on the other review. There was a couple of them that were repeated, but let me go ahead and do this. You got 410 students surveyed. Here it is, 9th grade, 10th grade, 11th grade, yes, no. It says, which number is the closest to the probability that a student will not eat food served in the school cafeteria? So here, given that the student is in 10th grade. See, given that is a conditional probability. That means we're narrowing our bottom of our probability. We're narrowing our total possible values in the bottom to those who are only in 10th grade. So I am only looking, I'm zeroing in on these values right here. So how many of those values are there? Well, 63 plus 47 is 110. So I'm zeroing in on these. I'm not even looking at anything else. Now, out of those, see, it was given that they were in 10th grade. Out of those, how many will not eat food? 47 of them. So it's 47 divided by 110. And 47 divided by 110 is 0.43 C. 0.43 or C. All right. Well, there you have it. That is both of the reviews that we went through in class. Obviously, there are so many things that you could look at in regards to studying and preparing, going back, looking at notes. Again, next week, we're going to talk through the reference sheet. We're going to talk through some calculator key presses just to make sure you guys are ready to go. So anyways, I hope that these videos might help a couple of people. If they do, then they're worth making it. Hope you have a great I hope your preparations go well and you're ready for our test next week.